Welcome to the review and preview problems 10-6 to 10-12 in the CCG book. 10-6 says a regular rectangular prism has a cylindrical hole removed as shown below. If the length of the radius of the cylindrical hole is 0.5 centimeters, find the volume of the solid. So what we're going to need to do is we're going to need to find the volume of the cube. So the volume of the cube is equal to the area of the base, 5 times 2 times the height, which is 6. So the volume of the cube is 60 centimeters cubed. To find the volume of the cylinder inside, we're going to find the area of its bases, which we take pi r squared. So if our radius is 0.5 and we square that, multiply that by pi, we get 0.25 pi, times that by the height of 6, and we get a volume of 1.5 pi centimeters cubed. We need to subtract out the whole, so if we take 60 minus 1.5 pi, we get approximately 55.3 centimeters cubed. Letter B says, what could this geometric figure represent? That is, if it were a model for something that exists in the world, what might it be? Also, how might you change it to make a better model? So an example of a shape that has some sort of a cylindrical hole in it could be a pencil sharpener. It could be a block that young children string. Could be a bead, or it could be a variety of different things. 10-7 says, in the diagram below, line segment AD is the diameter of circle B. If the measure of angle A is 35 degrees, what is the measure of angle CBD? So looking at triangle ABC, and knowing that this side and this side are the radius of our circle, we know we have an isosceles triangle. So we know that our base angles are both congruent at 35 degrees, 35 degrees. When we take 180 and subtract 35, both 35s, we get 110 degrees. So this angle is 110 degrees. So in order to figure out angle D, or CBD, we want to take 180 minus 110, and that tells us that our angle is 70 degrees. If the measure of angle CBD is 100, what is the measure of angle A? So I went ahead and erased our picture because now we want to know if the measure of angle CBD is 100 degrees, what is the measure of angle A? So we can go about this the same way. We can take 180 and subtract 100, so we know this top angle is 80 degrees. We know our entire triangle has to equal 180, so we can take 100, divide it by 2, which tells us both of our base angles of our isosceles triangle are 50 degrees. So if the measure of angle A is equal to x, so if this measure is equal to x, what is the measure of angle CBD? So if we take x, these angles would both be x, and this angle here would be 180 minus 2x. Then in order to find CBD, we would take 180, subtract 180 minus 2x. So the measure of angle CBD would be negative 2 times x. And then don't forget 180 minus 180 is 0. So our solution is just 2 times x equals 100. 10-8 says Lavina started a construction of below. Explain what she is constructing, then copy her diagram and finish. So Lavina appears to be constructing an angle bisector. So with your compass, after you complete your other mark over here, when you connect those points, it should be a bisector of angle BAC. 10-9 says a sector is attached to the side of a parallelogram as shown in the diagram below. Find the area and the perimeter of the figure. So looking at our figure, we know that the top of our parallelogram is also 15 inches. If we create a perpendicular bisector, we know that this angle is 90 degrees, which would give us a 30-degree angle here. Which, because we have parallel lines, we know that this angle is a 60-degree angle. The other thing we know is we are dealing with a circle over here. So to find the length of our circle, we need to find the circumference, which is 2 pi r. We know our radius of our circle is 12, so if we do 2 times 12, multiply that by pi, we get 24 pi. Except a whole circle is 360 degrees divided by 60 tells us that there would be 6 pieces or 6 slices of our circle, so we want to divide that 24 by 6, which would give us 4 pi for the length of the blue length of our arc. We could also find the area of the circle by pi r squared. So our radius is 12, so 144 pi. Again, divide that by 6 because we have 6 pieces. So when we divide 144 by 6, we get 24 pi inches squared for our area. So because we're working with a sector of a circle, we know that both of these essentially would be our radius. So this length would be 12 inches as well. So when we find the perimeter, we're going to add up all of our sides. So we're going to say 12 plus 15 plus this whole length, we're going to call 27 plus 4 pi inches gives us about 66.6 inches. When we talk about our area, we found the area of our sector over here in blue. Now we need to find the area of our parallelogram. So we need the height of our parallelogram. So looking at this, we have our hypotenuse, which is 12. We need this piece of information right now, and we know both of our angle measures. So we can go ahead with either 30 or 60, whichever you prefer. So if I do 60, I'm working with the sine. This side is opposite, so the sine of 60 degrees equals my opposite side over my hypotenuse. The inverse of division is multiplication. So I get the height is approximately 10.39. So in order to find the area, I'm going to take my height times my base. So 10.39 times my base, which is 15, which gives me approximately 155.85. I then need to add the area of my sector, so 24 pi. When I add these together, I get the area is approximately 231.25 inches squared. 1010 says, for each recursively defined sequence, list the first 5 terms and identify the sequence as arithmetic, geometric, or neither. So looking at sequence A, it says A sub 1 equals 17. So they gave us term number 1. A sub n plus 1 means to get to the next term, we need to take the term we're given and add a negative to it. So it would be 17, negative 17, 17, negative 17, 17. And in this case, we were multiplying by negative 1. So this is a geometric sequence. So arithmetic is adding or subtracting to get from one term to the next. Geometric is multiplying or dividing to get from one term to the next, and neither is a pattern that is different than either one of those. So looking at this next function, they give us term 1 is 32. They say to get to the next term, we need to take half of 32 and then subtract 5. So half of 32 minus 5 gives me 11. Half of 11 minus 5 gives me 1/2. Half of 1/2 minus 5 gives me negative 4 and 3/4. Half of negative 4 and 3/4 minus 5 gives me negative 7 and 3/8. When we look at letter C, our first term, this would be an example of neither because we are neither multiplying, dividing, adding, or subtracting to get from one term to the next. Looking at letter C, it says our first term is 81. To get to the next term, we are just going to use the previous term. So our sequence is 81, 81, 81, 81. And this would actually be, we could multiply by 1, or we could add 0 to get from one to the next. So we say this is geometric and arithmetic. (10-11) says on the same set of axes, graph both equations listed below. Then name all points of intersection in the form xy. How many times do the graphs intersect? So if you're doing your homework online, you can definitely use the e-tool to help you graph this using the Desmos app. If you are not, you can graph it by hand or use the technology you have. So the first equation represents a line. So I'm going to start at -7. Be really careful that you look at your axes, because in my graph, my axes counts by 2. So I'm going to start at -7. This is my y-intercept. My slope is 4 over 1. So I'm going to rise 4 and run 1. Rise 4, run 1. Whoops, I went over too far. Then I can connect my points for my line. I'm going to graph this as a quadratic function. Looking at it in standard form, I know my y-intercept is at +2. I also know that this quadratic is going to open up because of my coefficient a being positive. I'm going to see if this is factorable, but there's no purpose in factoring because if so even though your y-intercept is above your x-axis, your vertex could still potentially be below it, opening up, so make sure you check and see if it's factorable. 2x squared goes in the top of my diamond, -2x goes in the bottom. What two things multiply to get 2x squared? Add to get -2x. So we have no combination. So this is not factorable. We could try plugging it into the quadratic formula, or we could test some other values using a table. So if we used an XY table and we plug in some additional values to the right, if I plug in 1, I get 1, so there's an ordered pair at 1, 1. When I plug in 2, I get 2, there's an ordered pair at 2, 2. I notice that my parabola is starting to go back up. When I plug in 3, I get 5. I notice that these two graphs intersect at the ordered pair, 3, 5, so there is only one solution to this system of equations. 10-12 is a multiple choice question. A penny, a nickel, and a dime are all flipped once. What is the probability that at least one coin will come up heads? So we could draw a tree diagram. So if we flipped our penny first, our penny has a 50-50 shot of getting heads or tails. So it's 1/2 chance, 1/2 chance. Then depending upon what you flipped, you would flip your dime, and that would be, so after you complete your tree, 7/8 would be the probability that at least one of the coins comes up heads.